At the heart of the universe lies a domain where time and light lose all meanings. It is one of the most powerful yet mysterious puzzles of our cosmos. Yes, we are talking about black holes. On this journey, we are going deep into the mysterious world of this dark giant to explore how they form, their role in our Milky Way, and what would happen to you if you crossed the ultimate boundary. Are you ready to confront the limits of science? Don't forget to subscribe and join us on this cosmic adventure. What exactly is a black hole? It's not an empty void. It is a region of space-time where an immense amount of mass is concentrated into an incredibly small space, resulting in the infinite density. Its gravity is so strong that even light, the fastest thing in the universe, can't escape. The very idea of this colossal gravity began in 1950 when Albert Einstein published his theory of general relativity. He conceived of space-time as a stretched fabric and massive object bend this fabric. Yet, even Einstein couldn't fully envision the extremes of black holes. Within months of Einstein publishing his equation, a physicist named Carl Schwarzschild found a solution, showing a region where gravity becomes infinite at a certain point. That was the first mathematical foundation for the existence of black hole. The most crucial boundary of the black hole is called the event horizon. It's like the edge of cosmic waterfall. Once you cross it, no matter how fast you travel, you can never return. Not even light can escape its pulse. Everything that falls past the event horizon is inevitably pulled toward a central point. That center is the singularity. This is where the mass of an entire star is crushed into a point of infinite density, and all known laws of physics cease to function. Although black holes are invisible themselves, they are surrounded by swirling gas and dust. As the black hole rapidly pulls these matters in, it heats up, emitting powerful X-rays. This is the key way scientists locate and study. How do black holes form? Their births begin with the death of gigantic stars. A star with at least 20 times the mass of our Sun runs out of nuclear fuel and begins to collapse inward under its own crushing gravity. Unable to support its own weight, the star undergoes a massive explosion called a supernova. If the remaining core mass after the explosion exceeds the limit, the collapse can be stopped. If the mass is slightly less, it stabilizes as a dense neutron star. But if it's over the limit, it continues to shrink until it forms an even horizon, becoming a black hole. Not all black holes are created equal. Scientists primarily identify three types. First, stellar mass black holes. These are the ones that result from the death of single massive stars, ranging from 5 to 100 times the mass of our Sun. Second, and the most massive, are supermassive black holes. They contain the mass of millions or even billions of suns in one location. They are believed to reside at the center of almost every large galaxy. Our own Milky Way center hosts one of these monsters. Third, and still largely theoretical, are primordial black holes. These are thought to have formed in the early universe during the first moments of the Big Bang. They could range in size from an atom to the mass of a mountain. Chilling questions. What happens if you fall into one? Because of the extreme gravity, the difference in the gravitational pull on your feet versus your head would be enormous. This differential force would tear your body apart, stretching it into a long, thin strand like a noodle. This terrifying process is what scientists jokingly call sparketification. Black holes are also responsible for another astonishing phenomenon. When they collide, they send out ripples through space-time known as gravitational waves. We have successfully detected these waves on Earth using advanced instruments like LIGO, completely transforming how we study the universe. Our knowledge of black hole is still in its infancy. The mystery of the singularity at the center remains unsolved. To understand it, we need a new theory that can successfully combine Einstein's theory of gravity with quantum physics. Projects like the Event Horizon Telescope are giving us direct pictures of black holes. And in the future, we hope to unravel even more of their mysterious secret. What we have covered is just the beginning. Black holes are beyond our imagination, yet they are crucial components of the universe. Although they swallow light, they shed light on the fundamental truths of our cosmos and our place within it. If you enjoyed this journey, please like this video, drop your comments below, and subscribe for more documentaries. See you in the next video. Thank you.